Together we have Dr. Tongpon Tukomin today, and then my name is Siwarat Bunjarat Karin. As a representative of SMS Corporation, today we are very thankful for the host of Bioplastic, Bioplastic, that let us share our concern on the waste pollution, the plastic waste pollution. At the same time today in this talk, we will contribute to solve the problem by the TAPIOPLAST. It is designed to be affordable, to be most compatible with more of the biodegradable resins. And I'd like to start my talk today by recalling an related issue on the waste, on the plastic waste that has happened to me and also probably to most of us. It was the time that I was in the first year in college, and it was a long time ago. I cannot tell you exactly how many years ago, but it's probably more than 20 years ago. So in such a young age, we have so much energy. My classmate and I would like to organize all the events to save the world, to save the environment. And one of the things that we cannot miss is recycling. The first thing we do about recycling is the plastic waste recycling. And again, the first thing we do is about trash talk. What I mean is that we will plan a campaign to go around and ask people to start sorting out their garbage, their trash into different kinds of plastic so that we can recycle them. We've done that in hope to solve the problem of the plastic waste pollution. And let's fast forward 20, 30 years from that time until today. What we've been doing on the plastic recycle for 30 years. What is the result of that? For the activity of recycle by itself, it is very prominent and mandatory in some places around the world. But if we look at the result of plastic recycling, gosh, we have to admit that after 30 years of recycling, almost all the plastic that we make, about 80-90% become waste. And then among these waste, 8 million of them enter the ocean every year. So by 2050, there will be more mass of the plastic waste than fish in the ocean. So we must admit that the recycling is doing its part, but only small amount. We have a big gap to catch up on recycling and in the plastic waste pollution. So we take the fact of this plastic recycling and try to analyze further what happened to the recycle of plastic. It started since 1970s. The truth is that not all plastic can be recycled. So single-use plastic, food packaging, dirty plastic, this will not be recycled. That's the inconvenient truth that we should accept it. And what we're looking at right now today, not all plastic can be recycled together. We have to categorize them into different types of plastic, and that would add another layer of complexity to recycle. And then at the same time, every round of recycle we done to the plastic. The mechanical process can damage the molecule of the plastic, and that will reduce the properties, the desired property of the plastic material. And then at the end, we have only limited a few times of recycle can be done. With all of this reason, only 10%, maximum 15% of the plastic are recycled around the world. And then at the end, the bottom line is that the recycle of plastic is not financially feasible. It will be cheaper to use the new material than recycle. So I like to make a conclusion on this slide is that recycle is activity itself, it's good. The result, it's doing its part, but only in 10 to 15% of recycle. So what do we need then? How can we make a plastic that can take care of the other 80% that are not recycled? So what we do today is that we have the material biodegradable plastic. It would be especially good if they make from renewable resources. So this would be the solution to the 80% of the plastic that cannot be recycled. And if we think about this carefully, if this plastic are made from renewable resources, it will be carbon neutral as well. The material will be made by capturing carbon dioxide in the air. We can use this material to replace non-recyclable plastic, about 80% of total production of the plastic. At the end of life, after usage, the plastic then will be biodegraded into carbon dioxide. It sounds very good. The plastic pollution can be avoided, and then we can move toward the sustainable world. But then, such a good solution, we should think about why biodegradable polymers can take up only 1% of the total volume of plastic produced. Why is that? The 1% that are biodegradable may be not good enough to solve the plastic waste problem. How can we make it better, right? The 1% is not enough. At the same time, it may create burdens in trying to sorting out the biodegradable plastic from the non-biodegradable plastic. So at SMA Group, we think about this very carefully, and we try to answer the question. We try to come up with the solution to answer the question. So we learned that the reason, although biodegradable polymers could be a very good solution for the plastic waste pollution, but there are obstacles that we need to overcome. The first thing is that the cost of biodegradable plastic today is still high comparing to other plastic. It could be 3 or 4 times more expensive. So most people will not like to spend money on this 3 to 4 times to buy the biodegradable plastic. But not only that, with the demand only 1% of the total volume of plastic, it will take a lot of manufacturer to enter, it will take much courage to enter this market. So the supply of biodegradable plastic is limited. And then at the same time, we cannot forget about the biodegradability. So many of the time, when we say something biodegradable, it may not be totally safe to the environment. We got to make sure of the fact that the biodegradation has to produce the final products of water and carbon dioxide. So therefore, we need to follow the standardized biodegradation. For example, the EN 13432 and the ISO 17088. So with this in mind, the bioplastic team at SMS, we take this issue seriously. We try to answer the question of the cost, the supply, limited supply, and the biodegradation. With this in mind, we set out to do a very intensive research to our several years to come up with a material that can answer the 3 obstacles. So the team make up of people from different backgrounds. We have scientists. Maybe I'll mention a few. We have Dr. Jesuda. We have Mr. Warashat, who is a scientist, and even the CEO, Dr. Wirewat, is also a scientist. In addition to that, we have staff from the business side as well as from the manufacturing side. We come all together in the past few years to solve this problem. I'll explain to you what we got as a result. So the first thing we say that this bioplastic must not be harmful to the environment. It will be something that easily degraded. And starch, modified starch, is the answer to those. The reason I say modified starch, because I'll explain to you later, starch alone cannot be directly used with other biodegradable polymer. Right? So with the uses of starch as a raw material, it is considered carbon neutral because starch are made from carbon dioxide that we capture from the atmosphere. At the same time, starch is a universal molecules. We can break down the starch into glucose, which are needed by many organisms. And most of them will take up glucose just like that, so they're not harmful to the environment. So with this that bioplastic, we can have advantage of fast biodegradability. We can increase the bio content. What we mean by that is that to capture carbon dioxide from the atmosphere, but not from the fossil. And then the cost of starch as a raw material is so much lower. So with this, the advantage, I summarize them on the left, the pros: cost effectiveness, high biodegradability, natural abundance, increased bio content, and good oxygen barrier. We still have problem to solve. Every time we use, if we use directly the starch, it will have poor mechanical properties. At the same time, because of hydrogen bonding in the starch, the molecule is very hard to process. And it is water sensitive and also have poor water vapor barrier. So with this in mind, we dig deep into research and try to answer this question. And the answer is here. The mechanical strength is every time compromised by the non-compatibility between starch and the biodegradable polymer molecules, other ones. So when you mix starch powder into the biodegradable material, the material itself is hydrophobic, but starch is hydrophilic. There will be gap, there will be space between the interface between the starch molecule and the biodegradable polymer molecules. And with this gap, with this space, it will compromise the desired properties of plastic. For example, the tensile strength, elongation will be lower. So what we have to do, these are examples of if what happened if we just use starch that is not optimized for its modification. On the left side, you'll see that these are the way it's supposed to be. We want a stable film blowing, continuous, so we can apply the starch resin with other polymer to make the film, for example. With the presence of starch, without modification, without optimized modification, without the appropriate modification, we'll have this cleavage, we'll have the crack, and it's not going to work. So we have to have a good design of the starch molecule. I'll explain to you how, in concept, three concepts, how we have to modify the starch appropriately to answer this question. The first thing is that we have to turn some of the polar character of starch into the hydrophobicity character. With this hydrophobicity character, the starch molecule can blend better with other hydrophobic biodegradable polymer. With this happens, we're not going to have gap anymore. The compatibility will increase the strength, elongation of the composite that compose of the starch and other biodegradable polymer. Second thing, the second concept is that we have to adopt the plasticizer. The plasticizer will disrupt the hydrogen bondings among the starch molecule. With this molecule, with the plasticizer, the molecule can slide to each other, and that will allow for the easier processing. So that will answer the second obstacle in the slide that I showed you before. And then the third concept is that we have to do cross-linking, either by physical or chemical modification. The cross-linking between the starch and the biodegradable molecules can increase the compatibility between them even further. And again, that will lead to the desirable plastic that we can use with the desirable property and at the same time biodegradable. So with these three molecular design concept, hydrophobicity, plasticization, and the physical or chemical cross-linking, we can come up with the best way to have bioplastic. And the name is TAPIOPLAST TPS. This is the molecules of starch that be compatible with other biodegradable polymer. Okay, so in conclusion, with the TAPIOPLAST, along with circular economy, we can see that the molecule is affordable. It made from abundantly supplied molecule. It is renewable resource. It can enhance biodegradability, and it's also compostable. And again, before I go to the Dr. Dongpong section, or like you guys to take this message home. So the TPS, the TAPIOPLAST, the cost is only a fraction of other biodegradable polymer. For example, PLA, PBAT, PHA, and PHB. It's all more expensive than TPS. And we can mix the TAPIOPLAST with this biodegradable polymer at 30% for many cases, and up to 60% in other cases as well, in case of tableware. So now I want to turn you guys' attention to Dr. Tuong. She will talk about the detail of the products that we have.
Good afternoon, everybody. So today I would like to start from elaborate to SMS direction on the bioplastic industry. SMS tries to overcome the cost limitation of the bioplastic market by making it affordable with better biocompostable properties by using agricultural products to complete the circular economy. So there are three keywords I would like to point out once again. First, try to make it affordable. Second, try to have a better biocompostable property. Third, try to serve the circular economy. First mission, try to solve the SMS to have bioplastic more affordable. As presented earlier, that both market size and market growth of bioplastics are low. This is due to too expensive cost of bioplastic materials. You can see that the price of PBAT, PBS, and PLA is about 3 to 5 times more expensive than conventional PP and PE plastic. So SMS launched TAPIOPLAST product, and we target the price about $2 per kg. So when this TAPIOPLAST was blended with these materials at the ratio about 20 to 30%, the total cost could be reduced. And by doing so, SMS hoped that TAPIOPLAST could be one of the key factors to drive bioplastic market to have a better and higher market growth in the near future. And second mission, better biodegradability. TAPIOPLAST TPS has taste for its biodegradability by using the ISO 14855.1 standard. After 60 days, TAPIOPLAST TPS exhibit percentage of biodegradation at 104%, which are much higher than cellulose result. In this test, they use a cellulose as a control. From this result, in combination with other three results, we get the DIN Circle certification to certify that TAPIOPLAST TPS is a compostable materials, and we are able to use the seedling logo onto our packaging to confirm the statement that our product is industrial compostable. And the third mission, we try to serve the circular economy. This is as same as Dr. Sivarat mentioned before. You know that TAPIOPLAST is made from tapioca starch. So we use the tapioca root and we extract the starch out. We modified it and then convert it into the into the TAPIOPLAST product, which could be then further convert into TAPIOPLAST compound and become TAPIOPLAST bioplastic, like shopping bag or garbage bag. At the end of the life, this bag will go to the composting and release out carbon dioxide, water, and biomass released back to the nature, where tapioca plant can grow from that again. This is how we close the loop of the circular economy. So now we finish with our mission. I would like to talk about properties of TAPIOPLAST TPS. These are specification and the benefits of the product. In the specification, we talked about the pallet size, densities, moisture content, and the bulk density. The shelf life of the product is about 1 year. Then the benefit of TAPIOPLAST TPS. First, as it is produced from tapioca starch, which is biomaterials, so you can claim for the higher bio content when you blend it with other petroleum-based materials. And second, as TAPIOPLAST TPS was modified to have a good compatibility with other materials, so you can observe the homogeneous film appearance and also good mechanical property of the finished goods. And the fourth, as it is our mission that TAPIOPLAST should make the plastic become more affordable, so the product can reduce the cost of biodegradable product. And the last one, it can be colored with a bioplastic to make it colorful. These are purposes of TAPIOPLAST TPS when combined with other plastic. First, TAPIOPLAST TPS can increase the biodegradability when it was blended with the PBAT, PLA, HDPE, or LDPE. And second, you can claim for the higher bio contents when it was blended with petroleum-based material like PBAT, PPS, HDPE, and LDPE. And how is that important? Because in some countries, like in Japan, your plastic must have a bio content at least 25%. So you can claim that. So you can claim that it is bioplastic, and at the end of the life, it will not go to the composting, but it will go to the incinerator. You burn it to get the energy instead. And the last one is the cost reduction. The TAPIOPLAST can do the cost saving for biodegradable plastic resin. So TAPIOPLAST TPS will taste for its performance in comparison with other TPS from the other brand by blending with the PBAT at the ratio about 25 to 75. And you can see that SMS results are higher for both tensile strength and the impact test. Moreover, we also observe the more smoothness of the surface. These are due to the better compatibility of our product. So why TAPIOPLAST? I would like to make a conclusion again about our benefit. First, it has a cost benefit. Second, have a higher bio content. You can claim for that. And the third one, it provides a faster biodegradability. These are the properties which are unique, and we can use it as our key of sustainability. I would like to introduce all of TAPIOPLAST products in the series. We have 3 categories. The first one, thermoplastic starch or TPS. Second one is a compound which is ready to use for the converter. And the third one is a finished goods. The first group is the SMS thermoplastic starch. The product can be used as a raw material to be blended with other compostable materials and make it into the compound. Because the product itself, you cannot use it 100% alone. To make the finished goods, you have to blend it with other material first, then you compound it. So you can use a compound to produce the finished goods. This is how it works. So the first product is TAPIOPLAST TPS. This is our first product and original version. We launched it in end of 2019. So then the next one is TAPIOPLAST TPS 420. This is the developed grade. We modified from the first version to have, let's say, better hand feel. The finished goods using TAPIOPLAST TPS 420 will be not sticky to your hands. It will feel better anyway. So the third one is TAPIOPLAST TPS FC. The product was designed in accordance to Japan Positive List standard to be used for food contact product. So you can use it for food contact grade. And the second group is a compostable compound. We call TAPIOPLAST TPS CG41D. This one is industrial composable compound. You can use it for film applications such as shopping bag, garbage bag, or using as a packaging of hotel amenities. For example, you can use it to wrap around the cotton bud here, or cotton pad, soap, toothbrush, razor, still so many after this. It depends on the imagination. Okay.
Miss,
And
sorry to bother you, Miss.
yes, yes,
I just wanted to request that if we can jump a few slides and
okay, okay,
conclude a
okay,
little early. I'm sorry, we are just kind of
okay,
lagging behind a
no
little bit.
problem. So I have compound which can be used for the nursery bag and also compound to be used for the drinking straw. And then we have the composable finished goods because SMS would like to launch the bioplastic product to be to create the awareness of Thai people to know more about it. So we have TAPIOPLAST shopping bag. We have TAPIOPLAST garbage bag, so you can put the food waste inside and go to composting together. And also have the TAPIOPLAST bio straw, which is a drinking straw that can be composed anyway. So I'd like to say thank you very much for everyone's attention. And I would like to say again that SMS will try to achieve the sustainable world with TAPIOPLAST, which is an affordable bioplastic. And if you have any question or inquiry, you can www.smscor.com. You can reach us to that way. Thank you very much.
Thank you, Shivaru and Kwangpon, for your excellent presentation and being part of Bioplastics. I'm sorry we had to cut you short a little bit.
No problem.
Yes, I'm sure this will not happen again when you participate the next time at Bioplastics. So thank you. Once again, there are a couple of questions which I would prefer to email them to you later, if that's okay with you. And have a great day, both of you. And thank you, SMS Corporation, for sponsoring and being part of Bioplastics.